well, good afternoon, everybody. Thank you for joining us today. My name is Dana Daum, and we have Prashanth Kumar here, and we are with the solutions team at Cisco in the enterprise networking business unit, working on the things that we have in the title here, the Cisco Validated Designs. So Cisco Validated Designs are a result of the testing that we do in the lab. I go and I break stuff that he sets up, he breaks stuff that I set up, and then we figure out how can we keep you guys from breaking it, and then we figure out the best practices, and then we document it in these CVDs. So I'm going to just give you a quick introduction to the CVD process, and then we'll go from there. So this is your typical challenge. Many of you are, I'm sure, facing right now is, your boss or your colleague, whatever, tells you, hey, I need this new network. Design and deploy something for me. And then you look at it and say, all right, what do I do to figure this one out? I got to have something that's, going to meet the needs today, but it's ready for the future. At the same time, there's all sorts of different options as far as platforms, design options. We want to make sure whatever the budget is that they give us, we deliver it on time within that budget, or then we won't be doing much more of that work. And at the same time, if we have problems with it, then we want to make sure that we can be quickly able to manage it and take care of any things that come up. So lots of things to consider if you get this challenge from someone wanting you to build a network. Now, a lot of you've come here to take a look at how you do a SD access network, and there's all sorts of best practices and things you can get from Cisco Live, the TAC cases out there, or TAC tips out there, the design guides. You start looking through it and you can just get buried by all that information. So we want to keep you out of that situation and make our recommendation that the best place to go, we feel, is go straight to the Cisco Validated Design Guides for these things. That will let you go from zero to running as quickly as possible and avoid all those kind of pitfalls that we've hit when we've been testing this in our labs. So this session today is going to focus mainly on these two guides here, the Software-Defined Access Design Guide and the Software-Defined Access Deployment Guide. We've gone through the process of modularizing a lot of our recommendations. Instead of doing one big guide, we'll let you select what makes sense for your environment. There are also two related guides that I put up here, the SD Access Segmentation Design Guide. So a little bit deeper dive into when we talk about segmentation in this session, if you want to understand what makes sense in your environment as far as do I do macro segmentation, micro segmentation, and there's like a handful of use cases. You can go through and look at those and figure out, oh, this makes more sense in my network. So that's the guide to go through for that detailed discussion. And anyone here thinking about or saw encrypted traffic analytics? Seen that yet? It was announced actually last Cisco Live, so a few of you. We have a guide specifically on deploying ETA in your network, and this is where you can, there's the situation now where everyone's encrypting everything that's traveling across your network. So how do you analyze that encrypted traffic and understand, is this some sort of malicious thing that's going on? It's encrypted, I can't see it. We don't want to do the decryption. That would, in lots of cases, not even be a viable option. And so, the smart researchers dug into it and figured out, oh, there's some things we can discover just from the headers and the sequence of packets and the time delays in between them, where we can actually capture a lot of that, even though it's encrypted. And so ETA, when you integrate that with SD access, which is what we're going to talk about today, when you do that, there are some things to consider. And if you're thinking about going down that path, take a look at that ETA guide with SD access. So those are most of the things in this kind of space. All these things are available at cisco.com/go/cvd/campus gets you to these specific guides here. But Go CVD will take you to the entire design zone where we cover WAN, data center, all these other kinds of topic areas. All right, now we have the privilege of being the only 1,000-level introductory course here at Cisco Live, so I'm glad you joined us for that. If you want to get into some of these deep dives on topics, a lot of people like to get into the nuts and bolts of things, and we're going to be talking about things at a very high level, like, say, Lisp and VXLAN. If you want to know how that actually works and functions in your network, there are different sessions here that you can do deep dives into that. So you can, if you're jumping in here, there are lots of topic areas to cover. So how did we get here? Well, we started off the networks from the late 90s to traditional multi-layer campus networks. I have 4 different examples of networks we're going to look at where it's basically the same physical topology, the hierarchical network design model that you'll see at lots of presentations at Cisco. And in this model, we can actually use the exact same hardware, turn on some different functionality. So I've used some different icons to denote different functionality. But I can build the same network of the same devices and do totally different functionality. For example, a traditional multi-layer campus network, logically it looks like routers connected to these other routers that actually have then layer 2 functionality at the edge. And when you do this, you'll notice that I have 2 options to exit from the layer 2 edge, and that means that then I have to introduce things like first hop redundancy protocols like HSRP, VRRP, all these things that we have to then tune and play with, and if we want sub-second convergence timers, we got to start tuning those things. That is the network that we've been building for quite a while, again, since the 90s. Some people came along and said, well, why don't we just take that same equipment, turn on some different layer 3 functionality, and we get this thing called a layer 3 routed access, where we take the routing function in these devices here. These devices here, we're now going to turn on layer 3 routing capability, and then in this case, we push the issues of layer 2 spanning tree, all that stuff, all the way to the edge, so it's not in the main part of our network. Works great. We love it. People would really like to use this, but unfortunately there are some applications out there that keep people from using that. So that's another option with that same amount of equipment there. And then this is the one that we've been talking a lot about in the, say, past decade is, well, why don't we do this? Why don't we take some of these devices down here and logically merge them? So I've got 2 physical devices, I've got redundant links into the devices, I merge them into a single physical device, and then I actually have a really simple topology here. These switches connected just to a router, and then if there's layer 2 access that's needed across those switches, great, it works fine. Flexible, easy, scalable. This is what we've been really pushing recently until now with SD Access. SD Access, we can do something even different. We can actually jump these routing boundaries, and logically we can overlay these things like a totally switched network, totally routed network. These are the kind of the flexible things that we have when we have this nice solid foundation that we built our what we call the underlay with, and then we overlay it however we'd like. All right. So now, again, some of the session numbers, I put them up there in case you're interested. This was my session yesterday, and that's complete. But all these things, I think you might have heard about it already, but go to CiscoLive.com. There's an online library you can click on, and you can get the sessions from this week. They'll be published in a few weeks, but you can see these sessions from any of the other locations like Barcelona or when we're in Mexico, those kinds of places. They're all out there. So what's different about SD Access? Well, it's not just about the topologies that we can build, but we're seeing now with networks there are different demands than we've ever had on them before. For example, the BYOD, bring your own device. That's been exploding across networks, and people want to do special treatment of those devices. We also have these things in the Internet of Things world, the IoT world. People are wanting to put security cameras. It makes sense. We've got this big network. Why don't we integrate our security cameras? Well, once you do that, then you've seen some things in the news about potentially people hijacking those systems and using them as launch points into our network. So these are the kinds of things that it'd be nice if we were able to separate that from our normal user, production traffic, our classroom traffic, our business traffic, our whatever our production traffic might be. And then also in the cybersecurity, we've had security concerns, even from the 90s with our networks, but now things have gotten really critical where people are hijacking systems and doing this, pay me some money to get your system back kind of thing. And we want to do whatever we can to segment our network and look at the behavior of our network in such a way that we can accommodate those kinds of concerns. And so the traditional networks, they can deal with this, but it's really a challenge. They're difficult to do segmentation on. We have complexity of the management of these things, slower issue resolution because you're going box by box, hop by hop, looking to see what's going on. So that our thought here is that your traditional network, something's got to give. We got to do something different there. And so this brought up the idea of software-defined access. So it's more than just the topologies, as I said. One of the keys that I like to think about here is the top one right there, identity-based policy and segmentation. Right now, today's networks, if we want to do some of these policies in our networks, what's in the network that we can do that with? I mean, we have IP packets going across our network, and inside that IP packet, where does it say anything in that packet about the user that's using that packet? Really doesn't. And you look at it, well, there's source, destination IP, UDP, ports, things like that, but nowhere in there is there a user identity. So we need to somehow tie that user identity into our communication, and instead of doing these huge firewall rules talking about IP addresses, we don't really care about what the IP addresses are. We care about the users and their groups and what they're trying to do. We care about the intent of what we're doing in our network. So that's why we're starting to look at doing this intent-based networking, in that we want to understand the user and what they're doing. And then, of course, we want to get all the human intervention that, where that causes, if I do some configuration on this router a little bit different than that router and they're not in sync, then I've got outages. We want to get all that human error thing out of the way as much as we can. And so we want to make sure that we automate that network setup. Not only that, we want to converge our wired network, which used to have its own set of policies, our wireless network, get them so that they talk in one world as one unit, one policy. So that's something unique to SD Access. And then in the end, once we've had our network deployed, we're going to need our insights into, did what I think I was deploying really end up being deployed the way I thought it was? Let's look at the telemetry out of my network and the analytics and see what's going on and make sure that the intent that I had for my network is actually what is happening there. So that was the quick introduction to what SD Access is. We'll dig into what the guides are. So again, we're going to go through and show you how you'd pick up these guides and deploy your network very rapidly, as opposed to digging through all the different sources to try to figure out the best practices. So we're going to start first with the architecture and components that are in the SD Access design guide. So the design guide is what we kind of internally, we call it like the what and the why. Give me the components, why I'm using them, and tell me about this network so I can make decisions on how I'm going to deploy the network, and then later grab the deployment guide and start deploying. So I've already mentioned the multi-layer campus design and how this changes when we go to the routed access design. We push that layer 3 boundary all the way to the edge, and this is the foundation that we're going to build our SD Access network on. So I'm going to take this physical network. It's going to be a routed access network. It's a well-known, well-understood thing, and it gives us a lot of advantages. It's very cookie cutter. It's good convergence properties. You eliminate all that layer 2 concern and push it to the edge. So that's not in your main part of your network. It's still there at the edge, but you're ready to go with that layer 3 in the core and the distribution. So this is going to be the foundation that we show you in the guide of how to build. Now, what we show you in the guide is building a foundation similar to what would happen if you use the underlay automation is what we call it in the DNA center, and I'll talk about that in a little bit. We show you an ISIS routed underlay topology, but it doesn't have to be what we show you. If you prefer to use what you're familiar with, your EIGRP, OSPF, whatever that might be, you can do that also, as long as you build this foundation that's the routed access foundation. Okay, now why isn't routed access deployed everywhere? Same thing we talked about. If you have this need to span a layer 2 protocol across these two devices at the edge, and some of the examples of these are like building automation systems, badge readers, imaging systems, all sorts of things that have this layer 2 requirement. The layer 3 routed access doesn't fit too well. But what if you could actually do this? What if you could take that routed access, layer 3 routed access, and then build either a layer 2 overlay or a layer 3 overlay up here? You get your choice. As long as we have that foundation, we build what's called a fabric on top of it. And then we don't get into too much of it, but we have a control plane based on Lisp and a data plane based on VXLAN. And there's some reasons behind that we go through into the guide. But the short story there is with Lisp, we have location, identification, separation. Okay, what's that all about? Like right now, if you have your machine plugged in there and you have an IP address, that is both your location and your identification. You're known by your IP address. If someone wants to send you something, it goes to your IP address. But you're also tied to the router that backs up that subnet, so that's your location in the network, is behind that router. When you start separating those, you have your identification. This is what in Lisp they call the endpoint identification space, EID space. Your IP address still stays on your machine. That's your identifier. But there's now a different IP address that's used for your location. So that's a location and identification separation. The Lisp control plane handles all that, so you can have the same IP address move to a different router, and we can still have it all function through this thing called an Anycast gateway. But again, these are the details that we don't get into too much into the guide. We just say, hey, this stuff works. Here's how you deploy it, right? and we show you how it works with some of the other components we have in there. Because we did the data plane in VXLAN, we have the ability to embed some things that help us with that problem I mentioned about identification. Like, we don't have to identify people anymore based on an IP address. We can identify their traffic by putting some extra bits in the VXLAN headers, and those will map to different groups. So again, this is just kind of what's happening under the covers, deep dives in other sessions, but so you're on the same page, we can use the mechanisms that we built here to break things up into multiple virtual networks. So I can have totally different, segmented networks at a high level. They don't speak to each other at all. And then within those, I can have different groups. So this green machine is part of the same group as that green machine, and they can communicate. And maybe these blue machines, they're in the same group, but they cannot communicate with the green group. So we have that flexibility now. We can do things both based on group identity and by totally segmenting our network. All right. To pull this off, we build that routed access foundation. All right. And then we build this thing called the campus fabric on top of it. Again, that's all the stuff that comes along with the VXLAN and Lisp that implement this. And the only things that are really to be concerned with here is your edge nodes. You need to make sure that those edge nodes are capable of what we're trying to do. So there are certain software requirements, certain hardware requirements. We'll go through that a little bit. Intermediate nodes here, these are just some of your potentially distribution nodes that are doing routed access. So layer 3 routed access talks, layer 3 from access to distribution to the core. Those nodes in the middle, they could potentially, heaven forbid, not even be Cisco devices. They just have to be devices that can pass IP packets. Only real requirement there is they might need a little bit extra MTU to handle the overhead. But there's nothing special going on in the middle. You can build that as big as you want. And then we have these border nodes. So this is your exit point from the fabric. The borders can be considered internal borders or external borders. It's just some nomenclature that affects how traffic is passed. External borders mean this is almost like my default gateway last resort. If I don't know where the traffic's going, say maybe the internet's out here and I'm communicating inside here, I'll go to the default border nodes, so the external borders. If I actually am in another section of the network, maybe a WAN or something, I have a notion of all my well-defined network devices there. I would use a concept of an internal border. So just some of the nomenclature that happens here. But in the end, you end up with these border nodes, and then there's the control plane node. Now this is what does all the magic of Lisp, handling who are the endpoints, where are they, behind which routing locator, the RLOC that you'll hear about with Lisp. That happens within the control plane. That control plane, I show it here as being a separate router off to the side, which it can be. You can do that, or that control plane functionality can be in these nodes. Say if you have, say, the CAT 9500 nodes there, they could be both the border and the control plane. You'll have, if you're going to do lots of these virtual networks, or actually 2 or more virtual networks, chances are you're going to want those networks to access some resources that are in common to them. So you might not want those 2 networks to be able to talk to each other, but you probably want those 2 networks to talk to something like a mail server or an internet connection, or whatever it might be, your central services in the network. So to pull that off, to get one VRF is what it ends up look like coming out of the fabric. To get one VRF to talk to another VRF, you use what's called a fusion device. So we can decide, okay, can this guy talk to this guy or not? And that gets handled here. And we'll actually see that. We're going to be doing a demo a little bit later, and you'll see how that works. Another component that's critical in SD Access is Cisco Identity Services Engine, commonly referred to as ICE. The Identity Services Engine is the management platform that renders the policies that we create. So we create things using a thing called DNA Center, which I'll talk about, and it actually talks to this Cisco ICE server, and the ICE server renders the policy into the rest of our network. All right? Yes?
So if you're in a brownfield, where would you even begin with a topology like this?
So the question is brownfield and migration. And there's a 2-hour class just on that, because it is a bit of a challenge if you're doing brownfield. In the case of, if you're talking specifically to ICE, there are requirements on this ICE server that people are like, that's a little bit stringent for my network, but we can use the ICE server as a proxy to what's already out there in the brownfield. As far as the topology, you're pretty much going to have to do it on a area by area basis, however it makes sense for you. But yeah, chances are you're not going to flash cut the whole thing. You're going to want to do it step by step, and that's what actually Kadar goes through in that session on migration later this week. So yeah, that is a challenge. SD Access Wireless. So in this case, things don't look a whole lot different as far as the topology. We have our wireless LAN controllers. So these are the same wireless LAN controllers you might be using for centralized wireless, connected out here to, say maybe you have a shared services distribution node wherever that thing is, it connects into your fabric, and then the only real difference is now we have these APs. So we have a wireless LAN controller that understands how to deal with fabric. It actually ends up registering into the control plane and speaks Lisp and passes these layer 2 MAC addresses into the Lisp control plane to deal with this. And then these APs actually end up being called, just call them fabric APs. The APs, instead of communicating like you were used to with CAPWAP tunnel all the way back for the data plane, now they use the CAPWAP for the decisions that are centrally managed. So how do I handle roaming? How do I manage this device? All that. So that's still CAPWAP, but they speak with the data plane coming out of that AP, coming up to the edge node switch. They use VXLAN, and then they become a part of these fabric edge nodes. So they behave just as if they were something communicating natively with VXLAN like the edges. Yes? Okay, so the question is, how does this kind of like compare to Meraki Wireless?
No, no, so if I want to deploy SD access, but I have Meraki Wireless, not Cisco native wireless, my topology look like for the design.
So the question is, if I'm getting it right, if I already have Meraki Wireless, how does this effectively integrate that with that? And that you would treat basically as an overlay to it. So Meraki Wireless would just kind of like be ships in the night to that. So you don't actually integrate the Meraki Wireless into the edge nodes like that. It's just ships in the night, basically. So. Okay. I think I got all what I wanted to cover there. Eye chart here, but lots of different platforms enable what we're looking for SD access. In the PDF, I have a number of hidden slides that kind of go through which platform makes the most sense in the different parts of your network. That's for your reference in the slide deck. All right, so then let's start deploying this stuff. Okay, so we go and pull out our deployment guide. We decide how we're going to deploy this. Now, we have some decisions, and this is the one that this guy here had. By the way, I forgot. Someone generated these nice little books for us with the CVDs that are relevant here, all printed out into one nice little book. And since you asked that very relevant question for this slide, I'll let you have one of those books. And what I really like about that book is you don't need night mode on it. You read it at night, and it doesn't hurt your eyes at all. It's great. I'm sure you're going to be reading that at night too, right? So SD access deployment, we're going to decide, are you ready for layer 3 access? It can be an impactful change. If you're not already doing layer 3 access, you've got to get that underlay deployed that way, right? Underlay protocol, are we going to use the IGP that we show you? Are you going to use the ISIS we show you in the guide? You're going to use your own, whatever flavor you use right now. Virtualization, do you know what you're going to be doing there as far as figuring out what kind of VRFs do we want, coming out of these fabrics, the virtual networks in the fabrics. Security policies, all these kind of things. Lots of things you have to think about as you're beginning to deploy this. And the thing that helps you with the actual deployment then is the DNA Center. So DNA Center is how we deploy the things in software-defined access. But we have to get to the point where we can start using DNA Center, right? So this thing manages our network, but we need the components going. First thing we have to do is we got to get this DNA Center appliance connected. And believe it or not, that's actually one of the first challenges. People will get this, it looks just like this server up here. People get this appliance like, okay, I've got 4 different Ethernet ports, and where do I plug them? 5, actually. And where do I plug them? These first 2 on the left are on the modular LAN on motherboard ports, and so they're 10 gig capable. They're SFP ports, SFP plus ports. And you use those for basically the heavy traffic stuff in your network. Basically, the one on the left is going to be if we do an intra-cluster communication. I'll talk about that in a second. The next one will go to the rest of your enterprise network. So we're going to manage that through a 10 gig. And then we also have the one, just like any server that you would have, there's the SIMC, the Cisco Integrated Management Console port, so that we can do kind of like the out-of-band management for this server itself, managing it. And then we have a couple other ports which are optionally used. We don't show you using those in the CVD because we like to make it really easy. You can basically do the whole management and of your network and connectivity to the appliance right through the one port. So cluster communicate. Yeah, go ahead. Okay, so the question is, Can you put one of these in a data center, or do you need one of these everywhere you have SDA? So great point there. The recommendation that we have in the guide is put it in, and here's my kind of air quotes, close network proximity to as many devices as you're managing. So yeah, you can have it in a data center. Hopefully that data center is plugged in somewhat close to all the devices that you're trying to manage in your campus network. You know, how far do I want to get into that? Is that enough, or you have more questions there?
I mean, you could have one that would manage multiple of these campuses, right?
Yeah. In that scenario, so there are some other sessions that talk about once you start doing that, what we end up calling, multi-site or multiple campus together. And then there are some considerations there of how we tie those together. So that's getting a little bit deep for the intro level, but yeah, basically where you can have it as in close proximity to your network devices you're managing as possible. And it's really not so much from the SD access side that we have, this recommendation. It's for the analytics piece that I kind of hinted at the end. We don't go through that in this guide. In fact, we'll have a guide coming for that. But the analytics piece can be pretty traffic intensive, I'll say. So that's why we make that recommendation. So yeah, that's perfectly fine to put it in a data center, or if you're lucky enough, put it right as close to your campus as possible. But yeah, we expect it probably not be across a low bandwidth WAN link. You'd probably want to be on a Metro E or something like that. Yes. Oh, here. Appliances only today. Yep. Yep. Here. Oh, okay. So high availability with the appliances. I got you. And I was going to mention that. So this port on the left here, intra-cluster communications. We can do up to 3 appliances. In fact, it would be exactly 3 appliances as a cluster. They would communicate using that port. Again, it's some pretty heavy traffic, so that's why we're using that 10 gig port on there. The guide that we have shows you how to configure it as a single appliance with that ready to go so that you can start layering the appliances on. So that's what's in the guide. Yeah. I asked the guys that too. Yes, why 3 appliances, not 2? There's some history there, and it has to do with some of the underlying, I don't want to say there, protocols and things where it made sense for 3 appliances. But yeah, I don't have a better answer for that. Why 3, not 2, or why not 4? Pardon me? Split brain? Yeah. Okay. When is 3 going to be supported? 1.2 version coming up, I believe is. Well, so there's kind of that notion of supported. It's actually in product. It's one of those in product beta things that we have. So you can plug it in. It will be supported by TAC, so it is supported. But it's it's considered. They're still testing to make sure at really high scale it's doing what they expect it to do. Yes. Okay, so the question is, you told me I want to put this controller in here. What happens if I lose this controller? Am I in big trouble? And the answer is, so when we decided to go this route with this DNA center as a controller, some people were saying, yeah, this needs to be the God box that controls everything on every decision of forwarding all the time. It's actually just for the provisioning. So if you lose it, you're not going to make any changes on your network while it's gone, but in the meantime, everything still functions as you'd expect.
What about the historical data? People don't connect the historical data, right? For the time when it's down.
Right, and yeah, and any data that it's collecting that would have been collected while it's down that's gone too. Yeah. Yep.
For the cluster, are these all in the same location, or can we have them geographically distributed?
For the cluster, they can be geographically distributed, but it's got to be within some pretty high tolerance. So Metro E is reasonable, but anything, WAN link, no, you wouldn't do that. Yes?
So there's no like spillover between cities?
So a failover on the order of cities, not unless it's like in a metro area, no. All right. We'll keep moving here. So we've got our DNA Center appliance plugged in, all functioning. Very first thing, one of the requirements is this will need access to the internet because it grabs all of its updates from the cloud. So we have options to have it go through proxies and things like that, but it does need access to the internet one way or another. Very first thing you do actually when you fire it up and get everything loaded, it's all plugged in, connect to the internet, it'll give you the option to download all these packages. You do that. I mean, the key ones here is SD Access is one of the packages that we're going to download. There are other things that we can use for the analytics and that, which if you choose not to use them, you don't necessarily have to load them. But that's the first thing to do. The Identity Services Engine. You're going to be using the Identity Services Engine for doing all of your policy rendering in your network. So you're going to be configuring the policy in DNA Center, but the rendering happens using Identity Services Engine. So how do those two tie together? Well, we have to turn on things like PX Grid, Platform Exchange Grid on the Identity Services Engine. Very quick and easy to do. You turn that on. Same thing with the external RESTful services on the Identity Services Engine. You turn that on, and that's the way we can make API calls into ICE to do some of these things. Then you jump back over to the DNA Center, and you define your ICE server that you just did that on. So that's all there is to tying those together into one cohesive system. All right. There's also the controllers, the wireless LAN controllers for enabling SD Access Wireless. That's pretty straightforward too. In fact, Prashant will show in the demo how we just suck that into the fabric from the GUI. So you have to have the controllers up and running and reachable, obviously, and we show you actually how to do that from the bottom up in the guide. So that's all you need to do there. Okay, so we'll be getting into the, we've set up our SD Access with DNA. We've set up the underlay. We've set up the DNA Center. We've set up the ICE. We've integrated the ICE. We've set up the wireless LAN controller, and we're ready to pull that in using DNA Center. That's going to get us going and ready for the live demo. And there's a question. Question is, the WLCs, can they connect to the edge nodes? No, they actually do need to connect from somewhere outside of the fabric. Right. Okay, so now, I guess I'm going to hand it on over to Prashant, and we're going to go to a live demo here.
All right, thank you, Dana.
Yep.
So before we jump into the demo, I just want to quickly go through the topology that we built up for the demo. So what I have here is a couple of 9300 switches, which is going to be my access layer, and 95, which is going to be my distributed core setup. What I have on the right-hand side up there is the DNAC connected, DNAC, the wireless LAN controller, the identity service engine, typical Windows server, which is going to do my DNS, DHCP, and Active Directory up there. I have Active Directory connected to ICE so that it can do an external authentication. And I have NTP and InfoBlock as well integrated up there. So what I've done is I've connected all those servers, the common servers that we have, to my shared services box up there. And this is basically my traditional network. I have my traditional campus connected to my shared services so that the rest of my network can use those services as well. And I've basically routed those services through my underlay EIGRP protocol all the way to Fusion. Right, so to connect my traditional network to my fabric network that I'll be bringing up today, I'm using BGP, and then I'm redistributing between my traditional network into my ISIS. Right. And yeah, so what I'll be building is going to be, I'm going to be simulating like a school environment when I'll be having two VNs. That's going to be VN Campus and IoT. I will be basically having faculty user group, student user groups, and bunch of endpoints like IP phones, security cameras, and vending machines connected to my the 9300 switches. Right. Sorry about that. All right, so let me go ahead and log in into my DNAC. Right. So when you log into DNAC, this is the home screen that you would see. Before I even start doing anything, I would like to do two things. One is to make sure that I upgrade my DNAC to the latest packages that's available in the cloud. And the second thing I would do is I would make sure that all my integration is up and working, right? So from integration to really quick at the integration, all I have to go is to settings, system settings. Yeah, so what you see up here is a quick overview of the integration. The green check mark here basically says my ICE is able to talk to DNAC, vice versa through my ERS connections and as well as my PX grid. It's the same thing with InfoBlock. So InfoBlock is basically a third-party IP address manager. If you're using that, if you have IP address pools already configured in InfoBlock, we can read it from there and have it imported in DNAC. Or if you have it in if you configure or add address pools in DNAC, we'll push it into InfoBlock as well. And we do the same thing for Blue Coat IP address manager as well. Right, so let's go back to our home page. Let me go ahead, start designing my fabric. So today I'll just go ahead and then build a site. I'm going to just go ahead, use for it as an example. And I can go ahead build a site. Right. I'm going to just do a quick search on the address. Right, I can go ahead and do the search up there. And I'm going to go ahead and drag drop at the right location, and then go ahead and add it. So what I'm doing right now is I'm just creating a network hierarchy for the site that I'm going to be building, right? So I'm going to be also adding a floor. So the floor is needed when you're doing wireless. So you can import the heat maps that you have in your prime. If you're already using a prime infrastructure, if you have a floor plan that's already up there, you can just export from prime infrastructure and have it imported here, right? So just for the example, I'm going to just downloaded a screenshot of this particular building, so I'm going to just go ahead and add it up there. So yeah, so once we created our network hierarchy, we can go ahead and start adding network settings. So what I'm going to be doing is, so this network settings is the common servers that I will be using throughout my site, right? So for example, like AAA or NTP, that is something that I want all my network elements to be having it. So I'm going to just go ahead and click network. And then you can, for the network authentication, for the network device authentication, you can either use Radius or TACACS. Both are supported. Since I've already have ICE integrated for the Radius, I'm going to go ahead and then pick it up from the drop-down menu. I'm going to do the same thing as my primary. I can go ahead and add my DHCP server. Add my DNS domain name. Add my DNS server, which is my Active Directory up here, which is my Windows server. I'm going to skip adding syslog and SNMP, but I'll go add my NTP server, right? And I'll go use the universal time zone, right? And I can go ahead and then click save. And so this is where I'm going to be adding my device credentials. So these are the credentials. These are my username, password for the DNAC to log into the switch and then start provisioning, and SNMP to do polling, right? So I can. Just gonna get enable password. Go ahead, save this. And I'm gonna go ahead and then add my SNMP. So I've already configured SNMP on my routers and switches. It's doing MD5 AES. Right. So as a part of my underlay configuration, what I did is I had L3 connection. I had L3 routed access. I had routing processor ISIS configured so that my devices would be able to reach my DNAC. And I've also made sure that I put in system MTU as 9100 so that we can support VXLAN encapsulated for the data traffic. And what I've also done is I've already added my username for my local authentication so that I could use that, and also added my SNMP. And these are the credentials that I put in there.
So what you actually have is the network underlay, the whole foundation that this is going on is already built up, right? And so now what he's doing is figuring out, all right, we're doing a network design, and we're going to use that infrastructure to build additional things.
Right. So the next thing I'm going to be doing is I'm going to be adding IP address pools. So these IP address pools are for my overlay clients to get. So as I said earlier, right, I'm going to be adding a few clients getting in. So I'm going to create a client pool.
So are you the DHCP server?
No. So the Active Directory, which is my Windows server, which is going to be my DHCP server. We are just pointing whatever IP address we do it here. So the VLANs that we create in our overlay network, it's going to have the IP address, the IP helper address as this one.
Oh, okay.
Yeah. Yes.
Just to go back to the device credentials, is that to discover underlay devices?
Yes.
Network devices, or for the newly provisioned edge?
Yeah. So that is to
So
discover.
for people in the
underlay.
back, he's asking, is the credentials, are they used just for discovering the underlay devices, right? And the answer is yes.
Yeah. Sorry.
And you need SNMP as well as on the device, right? To discover that.
Yeah.
Yeah, SNMP on the device also. And then you'll see you can choose how to discover it if you want to use, you can do like CDP walks and things like that. But you know, for expediency in here, I'm sure Prashant will probably put in your hard-coded range of IP addresses that we're going to discover. Yes? Yeah, so that is, okay, so he's pointing to an external DHCP server, and we do have options to integrate with things like info blocks. So if you have your own IP address manager, your IPAM, we can integrate to that also. So the pools that you're creating, what are you creating pools for?
So these pools are for my Fabric overlay clients, right? So when I get my clients on board onto the Fabric, so this is going to, the endpoints is going to get IP addresses from these pools.
But
Right.
that's what I was asking earlier. So
So you don't need a DHCP server?
yeah, that's what, so is this pointing to the DHCP server, or is this handing out the IP addresses as a DHCP server?
So what we're doing up here is we're basically creating a VLAN, right? So in the VLAN, you're going to have a subnet, like a default gateway or a network command. So whatever input that we give up here is what's going to get created on the switch.
So you're just creating the IP range
Exactly.
for the VLAN. That's not necessarily assigning it. So
No.
somebody can do static or not, but if you want dynamic assignment, you point to the DHCP for that range for that VLAN.
Yep, exactly.
This is basically the new way for us iOS people to go in there and create interface VLAN 20, apply an IP address,
Yeah.
all basic stuff. This is doing the exact same thing.
Right.
You're doing it from DNA Center.
Yep.
Yeah.
It's the same thing.
Yeah.
It's just going to be pushed to the switch. The switch is just going to basically hand
right.
Yeah,
Yeah.
so some of the I don't know if everyone's hearing some of the comments here, but basically what this is doing is basically reserving pools. It's not actually assigning the addresses out from the pools. That comes from the DHCP server.
Yeah.
So the question is, do you need to know ISIS routing to get this to work? The answer is no. Yeah, the underlay, although you could have this do the automated underlay and it would deploy IS for you, that's one option. You can use whatever underlay routing protocol you want. As long as you're doing the layer 3 routed access, you're okay with whatever you want there. Yeah, so the question is, if you automate the underlay provisioning and then you log into a switch, do you see the CLI like you would expect to see on a switch? The answer is yes. I would still caution you though, once you've had DNA Center, take over the provisioning of the switch, it's probably not a good idea to change anything. So you want to keep the controller in charge of what's actually configured and pushed on the switch. Another question here. Yeah, so this question is, will DNA Center overwrite configurations? Yeah, it's best to leave DNA Center managing the switch. Yeah. Yes?
So if you do have the SSH and config, will the controller, the DNA Center will then push that config back down? Does it know when it's out of sync?
I didn't think I heard the first part, but I think I got the gist of it. Is basically if you start changing stuff, would it get out of sync? Yeah, you don't want to be in that situation. Avoid that.
It won't like detect the config on a particular.
That's not there yet, I don't think. They've discussed doing something that triggered it to make sure that they know if something's changed. Should we be careful and put cautions? But I don't think they've implemented that, even in the latest versions have that. Okay.
You're right.
Yeah. So we haven't seen that implemented yet, but that's something that we're talking about.
Yeah. All right. So I've created a bunch of pools that I'm going to be using later when I create my Fabric overlay. So I basically created, I'm going to be having APs connected to my Fabric edge. So I'm going to create a pool for the AP. So I created a pool called client pool. So this is where my faculty or students, when they come in with their endpoint, they'll get an IP address. So I've created an IP pool for my security cameras and vending machines so that it gets an IP address from those pools. Same thing with IP phones. So I'm going to put my IP phones in a voice VLAN pool up here, right? So once you do that, you can go ahead and then create your wireless SSIDs that you want to be advertising in your site, right? So creating wireless SSIDs is as simple as just adding it here. So you can just go ahead, I'm going to just say secure. I'm going to choose if it's going to be data or voice VLAN, right? And then I'm going to go ahead and then enable Fastlane. So when you enable Fastlane, we are going to be enabling 802.11k, V, and R for the WLAN, so that when you have users having voice applications, right, they will have a better user experience, right? And also it's going to help you with a lot of roaming scenarios. Yes? I don't think they have WPA3 right now. Yeah, exactly. So
Can you
we
repeat
will.
the question? Because I
Okay.
actually didn't
Yeah.
hear it
So
either.
saying like, if I understand the question is like when we will be getting WPA3, or when WPA3 is going to be there, is it going to be updated so that you can use that? We might have to see at this time. Yeah. Yes, sir.
So on the preview screen, you're creating the different address pools. I've been to several of these sessions, you're using list to obscure that address and let it be mobile, and you've got, the SCTs to control the access. So why not separate IoT and phones and computers into separate pools if you've got all this segmentation built in to the security problems? Why are all these presentations kind of showing that?
Yeah. Do you want to do that, or you?
Yeah. So I'll start and then you can do it. So if I go back to my IP pool, so I'm trying to create one IP pool for one particular virtual network, right? So if I use the client pool, I didn't say I'm going to be like exactly what you mean, right? I'm going to be having students connected, I'm going to be having faculty connected. I might be having some admins connected to the same pool, but they're going to get segregated based on the SGTs, right? It's just one pool, different user group, different devices will be using the same pool. So what we're trying to do is we're trying to create two virtual networks, two different virtual networks. One virtual network for IoT specifically, and then one virtual network for campus, right? So as a part of the campus, you would see all the production or all the faculty students coming into that. So I'm going to have a pool for that virtual network, and I need a different set of IP pools for a different for the other virtual network. Right? Does it? Sorry. Exactly.
It's
right.
just like creating VRFs.
Yeah.
In fact,
So,
the handoffs would be VRFs, and in Lisp terminology, it'd be VNs. And really, the big key difference, and again, we have a whole, because that question comes up a lot, we have a whole guide talking about why would you use one, what some people refer to as micro-segmentation instead of macro segmentation. And the biggest thing is, do you want absolute separation of control plane or not? Some people have that requirement, some people don't. It depends on, whatever kind of compliance things or whatever you're trying to achieve in your network. And so, again, if you're interested in that one, there's probably a half a dozen use cases that we've gone through of where you might want to pick one or the other in that guide that might be helpful for you. Was there another hand somewhere?
Yeah.
Or, okay, carry on.
Okay. Yeah, so going back to the wireless, yeah, I can go ahead. There's basically three options, three levels of security that we can do. You can either do .1x. Here I'm choosing the WPA2 Enterprise. You can also do your pre-shared key. You can select it and then create a passphrase, and then you can use that when you connect to a machine. And then you can do your open authentication. So let me go ahead and click next. So I'm going to create a profile. So this profile is basically grouping all the SSIDs which have the same characteristics, right? I can have, I'll create one more and I'll show you what I mean by that. So I'm going to just say profile 1. I'm going to say this is part of my fabric, and I'm going to choose which side is this SSID is going to be broadcasted in my network, right? So I'm going to say this is going to be, I'm going to be using this throughout the convention center. I can go ahead and then click that. Right, and then I'm going to just go ahead and create finish, right? Let me go ahead and then create a second one. I'll just go ahead and do PSK this time. I'll just select data, and I'm going to give a passphrase that I'm going to be using later, and then I'm going to next. So instead of me creating the profile every single time I create this SSID, I can just go back and refer this. So when I refer this, that SSID is going to be for that location that we selected earlier, as well as it's going to be part of the fabric, right?
The question is, can you still use Flex Connect with this? No, this is independent of Flex Connect. Yes. Yeah. So I think the point you're making here is this is not an exclusive thing. You can still do your other stuff in your network as you choose to do. So yeah, you can still do local mode and Flex Connect elsewhere, but not as part of this setup.
But somebody else in the fabric, is this access point handing off to the local switch?
Yeah.
Yeah.
So the question is, what's the handoff? Yeah, from the access point, it needs to be connected directly to a fabric edge, and that handoff from the access point to the fabric edge is VXLAN encapsulated traffic, actually. So, yeah. And
yes.
While you're creating the SSIDs here, you still got to go, to ICE, I guess, separately and create, whether you do TLS, certificate based, but you guys still got to set all that up to go with these SSIDs as well, right?
you want to do that one?
No, we don't have to. So ETLS is going to be for certification based, right? So what we are trying to do is the certification is going to be between your AD and your client, right? So what we are doing is we're just giving username password here. We're not doing any certification based at this time.
So there's no option to automatically create one?
No, yeah, not at this time.
I think what he's saying is you still
Yes. Right, yeah. So you still have to do your ICE profiling though, right? Meaning you have to create authentication profiles, you have to create authorization profiles. That still needs to happen. Yeah. No. So what DNA, I'll walk through when I'm doing the demo. What DNA does is it'll add the wireless LAN controller as a part of the network device, and you can just pre-use the default profile that comes in the ICE. As like you can either pick .1x, map, things like that. Once we'll go up there, and then I'll show you what we need to do to get it working as a part of the demo. Right. Okay. All right. So yeah, let me go ahead and then. All right. So once we do this, we can go ahead. We created SSIDs, so we can go ahead and then you can use DNAC to upgrade or downgrade your switches, right? So if you want to do that, all you got to do is just go ahead and click import. Then I'm going to just choose a file that I pre-downloaded onto this machine, and I can go import it. So you can use, all you got to do to upgrade your switches or downgrade your switches is basically select the image, select the switch as a part of the golden image, and then once you discover your devices, DNAC will look at the image that is running on your switch and then compare that to the golden tag that you have picked, and it will basically show you if it's as an outdated if it doesn't match. And if you want to upgrade the switch, all you have to do is just select the device and click Update OS, and it will basically go ahead and then upgrade. I'll show that how to do that in the demo as well, like once we discover our devices, right? So yeah. So this is what we would do at a high level, so in the design, and then let's go ahead and then create the policies, right? So when I talk about policy, I'm going to be, what I mean by policy is creating those scalable group tags, the user tags, and also creating those VNs. So when we integrate ICE to DNAC, we would basically import all the scalable group tags that's already defined in ICE, and then show it up here, right? So if you see, so some of the active SGTs, the scalable group tags, is what is predefined in ICE. And if I want to add more, all I have to do is just go ahead and click Add, and go ahead and log in.
So
Yes.
you still have to configure ICE completely, then DNA is just importing it? You can't?
Yeah. So when I mean you completely, it depends, right? So when I mean, so when you say, this is a fresh installation ICE in this case, so I've not configured anything. The only thing I've done is I've created my authorization profile. I'll just show you in a minute. So I have, if you go back here, I don't have any devices discovered, right? So I don't have any policies that I've created yet. So I'm going to go ahead and create those policies right now, right? So those policies are basically, once you get authentication, you do authorization. As a part of authorization, you hand that SGT based upon the user group, right? That's still.
You have to go here and define the devices, the subnets, and everything else?
You don't have to do that in ICE, right? Yeah. Any other questions?
Yes, you want to repeat that for the rest of the crowd?
Sorry. I keep forgetting, sorry.
Yeah, so he's basically asking, do you have to go and configure everything in ICE first? The answer is no. What happens, ICE is just used to render the policy out into your network. The configuration is actually done in DNA Center. So what he'll show during the demo is that the things he configures in DNA Center, you'll see like when the devices show up, they'll automatically show up in ICE, and then the policies that he pushes show up there too. So.
Yes.
The SGTs you have now, were they configured in ICE previously, or did you configure them?
So the 16 SGTs that you are seeing right now it's by default. When you install it, you'll get those 16 SGTs. These are, yeah. So that's what I'm going to do. You can add your own customized SGTs based upon your needs.
So it's greenfield-ish.
Yeah.
Not like 100%
I'm not sure what you mean by greenfield here.
It's not like you can just like blast out a VM device, hook it up in the DNAC, you're good to go. Like if you have
Yeah. So if you already have an SGT that is already predefined as a part of your existing infrastructure, you can always go back and leverage the same SGTs. You don't have to create new, right? Does that answer you? Yeah. All right, any other questions?
The version of ICE, that's,
Yeah, so this is ICE 2.3 patch 2, right, yeah. And the DNAC version that we are doing today is DNAC 1.1.4, right? Yeah, so let me go ahead and create the scalable group tags. I'm gonna create one for the faculty user group.
by the way, I'll just do an aside there based on that question. The deployment guide, what we've gone through and we've done end to end as we built this in our labs and tested it. The actual versions that we use during that testing are what you'll see in the back of the guide. So there's an appendix there with every version that you might be interested in, from the switches to the ICE version to the DNA Center version and packages within DNA Center. They're all in the back of the guide. And 1.1.4 actually was the version that was validated within the guide. 2.3 patch 1 was in the guide. He's on 2.3 patch 2, but either way, they're both supported with 1.1.4.
So the SGTs, when you go to the DNAC Center, you just click on it. It will basically redirect you to the ICE right component, right? So you basically come to ICE and then you create it in the ICE, right? Right, so I just went in and created a few SSIDs, few SGTs. So when we had it up here, DNAC would just go ahead and then read it and then auto-populate it in its table as well. Right, so if I go back here, just do a quick refresh, and you would see the SGTs that I just created, like faculty, IP phones, printers, and others, right? So while we are in ICE, we can quickly go back and change our policy sets so that when, yeah, go ahead, sorry.
So as soon as we hit save, it automatically populates?
Yes,
Okay.
yeah. Yeah.
If there was like a polling interval or?
No, the ERS connections that we make, that will basically push the configs right away to the DNAC. So all you gotta do is just save, and then it'll refresh the page in the DNAC.
The question was, as soon as you click save,
okay.
does it push that out? And
Yeah.
question.
Real quick to verify, if you create a group within DNA, will it push it to ICE?
So there is no way, the question is like, can we create security group tags in DNAC and then it pushes to ICE? So there is no button for you as of today that you can create SGTs in DNAC. So when you go ahead and then click add groups, we'll basically redirect you to the ICE. You have to create it there, and DNAC will learn it from the ICE. Right. All right, so yeah, so going back to ICE, so what I have here is I basically use the default that comes with the ICE. I'm doing map here. So I'm going to say, doesn't matter if my endpoint can do wired or wireless, as long as it can do map, you're going to authenticate to that. It's the same thing with .1x as well. So what I've done here is .1x authentication. So it doesn't matter if it is wired or wireless, as long as the endpoint can do .1x. I'm going to change the authorization profile to basically say match on the user group in my Active Directory, and based on that, I would just go ahead and then assign an SGT tag to it, right? So these are the only two things that you will be doing in the ICE. Right, I'm going to just go ahead, click that, and click save. Right, so yeah. So once I do that, I can go back to my DNAC. Right. So the next thing, what I'm going to be doing is I'm going to be creating my virtual networks. So creating virtual networks is just clicking on this button, and I can go ahead and then create, just say VN campus. And this virtual network is going to be having, I'll be adding faculty to be part of this VN. I'm going to be adding faculty SGTs to be part of this VN. You got a question?
It's got the P campus.
Oh, okay. Sorry.
I don't know if that would matter
Yeah,
later.
no. It's just a name that we are giving, right? So when we create our VRF, we just use a name for it for us to recognize. So it can be anything. But yeah.
And so all you did was drag and drop those groups right in there.
Yeah.
Right?
Yeah. So if you see, I've just these are all the default SGTs that are available from the ICE that we learned. So all I'm doing is just picking and then dragging from left to right, right? Student here, right? I'm going to be, I have these 3 SGTs as a part of this virtual network. I'm going to go ahead and click save. Right, I'm going to create another virtual network just to add my IoT devices, right? I'm going to just pick vending machine as a part of that, and as well as my security cameras. So by default, security groups within the same VN can talk to each other, right? It's always permit, right? But SGTs from one VN cannot talk to the other user groups in a different VN, right? So when it's 2 different VN, we call that as microsegmentation. Then if we want to do microsegmentation, the microsegmentation is within the same VN, right? So I'm going to go ahead and click save. So in this example, we don't want our security cameras to go talk to our vending machines. We want it to be completely isolated. So in order to do that, I can just go ahead and create policies, right? I'll just go ahead and then create one, call this as microsegmentation 1. Right? And then I'm going to just say vending machine as my source group and my security cameras as my destination group. I'm going to drag there. I'm going to add a contract saying deny access to it, right? So even though both these scalable group are part of the same VN, they won't be able to talk to each other at this time. And I'm going to enable bidirectional, and I'm going to go ahead and then click save, right? So when I click save, yeah, go ahead.
Yeah, sorry, I'm not an ICE expert. But ICE creates the
Yeah.
SGTs.
Right. Yeah. So what I did was all I did was created the tags, right? Once I create the tags, now I'm doing microsegmentation. So you don't have to be an ICE expert to do all this, right? It's as simple as dragging and dropping. I don't want my security cameras to talk to vending machine, right? You just created that. So what we do in the background is we take your intent, we push it to the ICE, and we would have a matrix that's created in the ICE which would block that for you, right? So when a user comes in, the device would go to the ICE, pull those the groups, the security group access list, or the policy that we created, and it would start blocking those things.
Is that trust set?
Yes,
Pulling from ICE?
exactly.
Okay.
Right.
So you don't have to do it just to the core.
Yeah, so you can just do it from DNAC, and then it will take care of doing it from ICE.
Yeah, so the question was, it's just like TrustSec. Yeah, this is basically TrustSec.
Right. Yeah. Yeah. We can also create, if you don't want one vending machine to talk to other vending machine, you can do the same thing. For example, you can just drag and drop has the same source and destination as the same machine, and you can do that as well, right? I'll just name this, right? So what I'm doing here is I'm just using the default contracts that comes with DNAC, which is permit and deny. But you also can go ahead and then create your own custom contracts, right? It can be port-based, right? In order to do that, so in order to create your own custom contracts, you'll go to the contracts tab up here, and then you can just go ahead and then add contract, and you can just say, I'm going to just deny HTTP traffic, right? I can just go here and then search for HTTP, and it basically picks up the port number, and then we can just select it. Right.
None of this cares about source and destination.
So the contract is basically your way of putting like what applications or what port numbers did you want to allow or deny, and eventually you're going to be using the same contract while you create your SGACL. So when you create your SGACL, you're going to select your source, your destination, and apply a contract. right?
Question over there too.
Yeah, yes.
Just quickly comment on the scalability of VMs and then security for scale groups.
Yeah, so
Can you repeat that?
yeah, so the question was like, what's the scale numbers, or what's the scalability for the VNs, the virtual network, number of virtual networks that we can create, and the scalable group tags that we can create, right? It depends on the platform, right? Certain platform will only support about the like 64 virtual networks. So it depends on the platform that you have in your network, right? Yeah, so for example, like 3850, you can only create up to 64 virtual networks, that is VRF, 64 VRF. But whereas you go to 9300, you can create up to 256 virtual networks, which is 256 VM, right? So it depends upon the platform, what you have in your infrastructure.
Yeah,
Right.
and just a side note there, if you're interested in specifically all the different platforms, what their scale is, we spent a bunch of time there. There are a lot of tables that we put in there to make sure that you don't get into trouble on that right within the CVD. So check that one out too.
Yeah. So I'm going to just go ahead click. Sure. I'm going to go ahead click HTTP port. I can create my own custom contracts, and I can use that during my creating my policies, right? So let's go ahead and then discover my routers and switches. So far what I've done is at a very high level, right? I haven't discovered my switches yet, so I haven't pushed any configuration onto the box. And all this configuration is at a very high level, right? So
These policies that you created, they're pushed up to ICE.
yes. So what would happen is all the policies that we create, we would push it to ICE, and ICE would give it out to the network devices.
Kind of a follow-up question. So in the example of the vending machines, you didn't want two vending machines to talk to each other. Assume they're on a VN or a VRF, where you have 5 sites, and they each have vending machines. Yes, they can talk to each other locally, but if they're all on the same verse, how are you preventing them from talking to them at the other side? Are you extending the STT across the border node somehow?
I'm sorry, I kind of lost the question there. So you're saying if I have vending machines within the same virtual network, and the idea was not to talk, not one vending machine talk to the other vending machine, right?
But now I have 5 sites. Each of them has a DNA center. Each of them has its own separate, distinct fabric at that point. How am I now preventing the vending machines from site 1 from talking to site 5?
So every fabric site is unique, right? It's independent from the other fabric site.
But I would assume my vending machines are on the same verse across all the sites.
Yeah, so so the question is, your vending machine, you have the same VRF across multiple sites, right? And then you have same vending machines connected with the same skill, with the same SG hackle or the policies that we created. So your VN and your SDDs are part of the same site, right? Once it hits the border, it's just an IP packet. It doesn't know what VN it is. It doesn't know what SDDs it has, right? So you'll have to create an SD hackle or IP access list to permit or deny the traffic, right? Yeah.
I get this earlier, and I don't know if you talked about later, a distributed model, but getting the hang of this in general, whenever I leave my local fabric, all rules and policies are lost as it hits the WAN and goes to another city. Then I have to replicate those in another city. I mean, you're doing a college campus. K-State campus has 3 campuses in different parts of the state or different parts of the country. I want students, faculty can get to whatever. I have to replicate those rules at each site. There's no DNA master that I am controlling teachers at these 5 campuses across the state or something? Or I have to do each one individually?
Right now, yeah, but there is a different ways that you can do it.
Repeat.
Yeah, so the question was, if I have different sites, right? So if I created a policy on one fabric site, will that be available on different sites, or I have to go back and recreate the same SG hackles at each site? So with this version, yes, you'd have to go ahead and then create at each site. But when it comes to distributed campus, I think you can create a ICE SXP connection and then basically download the SDACL that you have created, right? So let me put this in a different way, because you're going to be having one ICE, right? Every site will be having different PSNs, right? So one administrative node, ICE, and there would be just a policy node, everything, right? You would have all the different sites, which is just going to be PSN node integrated to administrative node, right? So when you go create an when you go create an policies up there, we're going to push it to the administrative node, and you can use the same policies throughout different PSNs, right? So you can, even though you have created it once, as long as it's part of the ICE cluster, you can go back and use it over multiple sites, right? All right, so let's go ahead and then discover our devices.
So while he's doing this, the discover, just the thing to point out, I don't know if it was clear that everything to this point, he's defined these VNs, all the groups and everything, and we haven't even touched switcher or anything yet. Once we discover the switches, then we can just say, hey, go ahead and do this for me and take care of it. So no need to jump switch by switch, all that. We do it as the bigger picture, trying to push the configuration down onto this fabric network.
So basically, the switches are, all you have to do is basically walk into a closet, plug it in, power it up, and walk away.
Yeah.
It's as simple as that. You don't have to do more consoling to them, no more anything. You just come to here.
If you use the LAN automation, you can do that. Yeah.
Straight to it. You don't have to touch nothing.
Yeah. That would be the LAN automation where we automatically, if you wanted to do that, plug a switch in and have it go, we'd use LAN automation to pull that. It would actually.
The only way you want to really look at one of the switches for any reason to SSH to it, just to verify maybe something got pushed to it at that point.
Yeah. So the question is, yeah.
We're testing it, make sure you're working at that point. That's all it really.
Yeah, right. The question or the comment is that, yeah, so once you've integrated all these switches into your DNA center and you built this SD access fabric, you know, what would you do? Why would you go into a switch and touch it? And the answer is you really wouldn't. In fact, you get, and we don't talk about it in this session, but with the assurance modules, you actually get a lot better information than if you were to just SSH into it. We can actually see some really good data out how our network's performing, what's happening with the groups, those sorts of things. So.
Are there tools where you, from a switch, you can generate, test packages, or you start pointing people and say, let me just generate something and act like it's something else you want to do, just to follow the path all the way through and make sure everything's working correctly?
Yeah, so the question of passive monitoring versus active tests, you worked with some of that, right?
Yeah, so for wireless, there is something called as sensor APs. So those are like very small APs, which is basically the size of my palm. What you can do is you can connect them to, you can basically simulate them as a client. You can you can push a profile onto the sensor AP, and you can say connect this to this SSID. Once it connects, you basically are checking authentication works or something of that sort. It's going to get an IP, so you're checking if it's going to get an IP or not, and you can send some kind of a synthetic traffic to make sure that the traffic goes end to end, and that is available as of today.
Yes.
Yeah.
So that's one of the key new things that you can get in the wireless world once you've integrated into SD Access is with these sensor APs. They're like that form factor. You can plug them in a wall somewhere and actually actively test your network before, say, a big crowd like this comes in and tries to use your network. You can make sure it's performing right.
You can schedule that for pretty much every day.
Exactly. Sit back at your desk and no body on site.
Yeah.
There was actually another question over here.
Yeah, up there.
Does the system support a password rotation policy? For example, if the company forces you
Yeah.
So if those credentials become updated in 1 week or something like
Yeah.
that, is there anything in that area?
Yeah, so what you have to do is you have to come back and then change the credentials here.
So I have to change the
Eh,
okay.
Yep,
Is
yeah.
there some kind of automated script or, I don't know, a vault in the system where I can change credentials for a certain username?
Okay, so the question was, if there is a need, if somebody is going to go ahead and then change the credentials, can I go back and then redo it in an automatic way instead of every time coming back and doing it here? So there are a few API calls that you can do, that you can go ahead and do it, and that is something that we might have to check with the platform team to actually, if there is any API calls available for do that. Right, yeah. Yes, sir.
The LAN automation that you mentioned, that's not part of the DNA center, is that right? Because in the demo, you'd already pre-staged all your switches with ISIS, SNMP, and local credentials.
Uh,
To the gentleman over there's point, the zero-touch provisioning, that LAN automation piece is something else that you would have to bring up, or is that part of it?
No, so your DNAC would take care of doing that as well, right? So what you would have to do is, it's just because we do not have so much time to do LAN automation, we just pre-configured it as a manual underlay, and then we're trying to use this. But it's just one tool which will take care of LAN automation as well, right? Yes, yes. So all you have to do, right, yeah, all you have to do is just bring the box up, connect to an upstream switch. We recognize that as Cisco switch. We put that, we basically configure loopback 0. We'll configure your point-to-point links. We'll put ISIS config on it, and we will automatically discover the device in DNAC. And once you discover DNAC, then you can start doing provision, right? So you don't have to go to the switch and then do anything up there, right? Yeah. Right. So let's do a quick recap of what we did so far, right? So at a high level, what we did is, oh, sorry.
Which one are you on?
No, I'm
You
here.
want to be on this one?
Yeah, just go change it, yeah. Sorry about that. So at a very high level, what we did so far is we created a network hierarchy, right? So when we created a network hierarchy, we created our sites, our floors, added our floor plan. Then we went in and we added our the shared services that we'll be using throughout different sites in the network, right? Then we created an IP pool that we will be using throughout our network, throughout our fabric overlay network, right? Then we created our SSIDs, right, that we'll be using throughout the site. Then we thought about our scalable group tags, right? Creating our user groups, giving a tag to those user groups, or thinking about the device groups and then giving an STT to that. Then we thought about our macro segmentation, which is creating virtual network, so that one user group will not be able to talk to the other group. And then if it's in the same VN, then we did something called as micro segmentation, right? Creating SG ACLs, right? So this is a quick recap. Yes.
The policies, is that common policies?
Yeah, so
Are they executed sequentially?
yes.
Okay.
Right.
So you have to pay attention
So
to that.
Yeah, so it depends upon, like when we created policy, we did not think about, we created random policies, right? When I say random, we created policies for vending machine. We created policies for security cameras, right? So what would happen typically is when an endpoint or an user comes onto the network, it gets a scalable group tag from ICE after authentication and authorization. Then the switch would go ahead and then download only relevant policies to that particular user group, right? It doesn't download all the policies that we created for all the other users. It's only going to download the relevant policies, and it's going to use the sequence, go from top to bottom, and then execute it. Yes?
If I want to use AD to classify the groups, do you configure in DNA or you still have to go to ICE?
You still have to go to ICE, right?
You want to repeat that one?
Yeah.
Within ICE, you can snag the groups from AD.
Yeah, right. So the question was, in order for me to, so you might have already created a user group within the Active Directory. Can I use that? So that was the question. The answer is basically you have to do it from the ICE, right? You can call the user group in the ICE, and then you can tag saying, hey, if the user is part of this user group, then you can go ahead and then give a different tag, right? Yeah.
Oh, you want to get back to
Yeah.
HDMI?
Sorry.
There we go.
Yeah. Right. So yeah. So in the meantime, all I did was I went in and discovered my devices. So to oops. Hold on. I know what is happening. Sorry. Yeah. Cool. So to discover your devices, there are two options that we have. We can either use CDP or an IP range, right? So CDP is you basically give one device. We can go up to 16 levels below through CDP protocol and then discover all the switches that is in your network, right? Or we can just create an IP range. You can just say, I want to discover my switches from this IP address to this range, and then go ahead and then discover, right? So those are the two options to discover. So if you see here, yeah, so I went in and discovered all my, the 9K switches as well as my Fusion router, which is part of my underlay, right? So if I go back to my DNA center, now I'm gonna be start provisioning my switches, right? So I can go to devices. I'm gonna select, right? So before we even start provisioning, there are a couple of things that we would have to check. We wanna make sure that the device is fully managed by the DNAC, right? So if you look at the sync status, we want to make sure that the device is in managed state, and we would also like to verify if the devices is running the right images, right? So so earlier what we did was we imported the image, right? So we didn't mark it as golden or anything. So if you mark the imported image as golden, what you would see here is you would see it as outdated if the switch, if the version that's running on the switch doesn't match what is marked as golden, we will basically point here as outdated. If you see that, if you want to go ahead and then upgrade your switch, all you have to do is select the image. From the Actions drop-down menu, you can just go ahead and then select the OS image, right? So what we would be doing is we would be going and checking on the switch if there's enough space for the image to be copied over, and then we're going to change the boot statement once the image is copied onto the box, right? So the reason why we are seeing this is I haven't selected any image as my golden image this time. So there is no target image that it needs to go to.
Question over here, Prashant.
And are all the
Sorry.
switches in install mode?
You can do both install and bundle mode. Yes. So the question was, can we do the image upgrade if it's a bundle mode or a install mode? And yes, we support both. Right. So let's go ahead and then start provisioning. Right. So I can do one switch at a time, or I can select all the devices at the same time, as long as they're part of the same family, right? As long as they are switches, as long as they are routers, as long as they are controller, you have to do it individually up there. So I'm going to select all the switches that I have in my network, and I'm going to go ahead and click provision. I'm going to just go ahead and then add this to a site, right? And I'm going to go ahead and click apply so that the same site is picked for all the devices. When I go ahead and click next, so this is what we're going to be pushing to all the switches in this, right? So these are all the settings parameters that we have set in our design page as a part of our network hierarchy. So this is what we'll be pushing, right? Our AAA, our domain name, our DNS, those informations, right? So when I go ahead and click deploy, I have two options. I can either deploy it right away, which is the option now, and if it's later, I can go ahead and then schedule it for a later time, right, during the maintenance window, or for this to get deployed. When I go ahead and click apply, this is when what we do is we push the configs to our routers and switches, to our switches. I've selected all my 5 switches, and I'm going to add this device to my ICE as well, right, so that it forms the trusted domain between ICE and my network device.
How does each one know if it's an edge device?
Yeah. So the question is, how does the switch know if it's what role it is? So we haven't even started doing fabric at this time. So we are prepping up to a stage wherein we can go ahead and then select the roles and responsibilities of it, right? I'm going to do the same provisioning for my wireless LAN controller as well. I'm going to put it to a site. I'm going to select all the APs that will be part of my this particular site, right? So when I do the provision, along with the network settings, you would see the SSIDs that we will be adding to our controller as well, right? So I'm just waiting for a wireless LAN controller to change from configuring to success, right? So, so if you go to ICE, I'll quickly show you what I mean. I'll quickly show if you can quickly verify if DNAC has added our network devices that we provision in ICE, right? If you see here, you would see all the devices that we just provisioned.
So yeah, you notice that those weren't there before when he clicked over there. Now that he's added them in DNA Center, it uses those mechanisms to inform ICE. Hey, you've got these devices that are going to be part of this.
Right. So let me go back to my DNAC. So this is the starting point for our fabric, right? So these are the prerequisites that we need to make sure. We need to make sure we have discovered our devices, we have provisioned our switches, and we should make sure that our switches are all in managed state, and the provision should be success before we go ahead and then create our fabric. All right. So let's go ahead and start creating our fabric. So I'm going to create a fabric domain called, I'm just going to go ahead and then say campus. Right. So let me go ahead and add. So I can go ahead and then change the device role. For example, I can just say this is part of my core or distribution or access. To make it look very similar to my topology, I'm going to just change this to core. So I have a Fusion box, a couple of 9500, my 93 switches, and wireless LAN controller, right? So this is where I'm going to be choosing the role, the fabric role of each device, right? So I'm going to be choosing my 9500 to be my border control plane. So I'm going to just go ahead and then say I'm going to make this anywhere. So yeah, I'm going to go ahead add my local AS number. Sure. And I'm going to select a pool for my border AP, border pool. Sorry. I'm going to
select the IP address pool that you created earlier, right?
Yeah. So I'm basically pulling out the pool that I've created during my design phase, right? So I'm going to select an interface. So this interface that I'm selecting is basically the interface that is going to be connected towards my Fusion router, right? So the idea is for every VN that we create, we would create a sub-interface or a VLAN based upon the platform that you're using on the border node. So the idea is to use those sub-interfaces or the VLAN to extend your VRF or the VNs to the Fusion router and then do route leaking at the Fusion so that all my clients can use that to reach out to the shared servers. Right. So I'm going to go ahead and then select all the VN. Right. I'm going to go ahead and click Add. I'm going to select another border control plane.
What network are you assigning it?
The IP pool. The IP pool that I created earlier during the network design page. So this is basically a different set of pool that is going to be used to configure my point-to-point links between my border and my fusion, right? Yeah.
You can see that at this point, DNA Center knows about all these devices, but we haven't really told DNA Center how do we want to deploy our fabric. You know, what are our edge nodes, what are our border nodes, and that's what he's going through right now, and getting the wireless integrated there.
Yeah.
So you haven't started the fabric config yet?
No. So this is all your fabric config is going to be. So all I did is I've discovered my devices, and I'm just selecting the role. I'm going to select all the role all at once and just click Save, and we push all the fabric configurations right to your box. Right.
Go with the controller.
If you see the CP up there, so that's going to be my control plane. My 9500 is going to be acting as my border and my control plane, right? So I have dual borders and dual control plane for the redundancy purposes. So anything doesn't show anything on the top is basically my fabric edges, right? So it is this simple to create our fabric at this time. So when I click Save, what would happen is we would push all the VXLAN, all the Lisp configurations onto the boxes, onto our routers and switches throughout the network and create our fabric. Right. I believe the question is like how many control planes can I have in a fabric? I believe it is 4. Am I?
No more than 4, yeah.
Yeah. Yeah, I can have 4 control planes, and I can have 4 border planes. So border, again, it depends. If you have internal border, you can have more. But if it's an external border, you're limited to 4 external borders. Right. So the question is, can we hack it? You mean the DNAC or? So what we do is there is a certs that gets pushed onto the boxes, right? So as long the certs is basically going to make sure that the connection is secure between our DNAC and the switches, right? Yes. Yeah. Yeah. Exactly. Yeah. I mean, then you'll have to think about ETA. Encrypted threat analysis. You can, if you think it's somebody's hacking, or you can.
I'm sure they've gone through it, but yeah, I can't give you like an absolute. Yeah, this is the most secure thing ever, but.
Yeah. Yes.
In your design here, you have your borders, you have a fusion that handles the route leaking.
Yes.
Where will you hang the WAN circuits? Let's say you have 2 WAN circuits coming to that campus.
Right. So if you have 2 WAN circuits, it's going to be beyond the fusion.
So they
right.
connect to the fusion box?
Yes. Yeah. So.
What's the fusion box of this?
So the fusion box is basically a route leaking, right? So you have your routes in your virtual network, right? So you have shared services that's part of your global infrastructure, right? It's part of your traditional network. So for the clients in the virtual network to reach the shared services, we are extending it to the fusion, and we are redistributing between the VRF that we created and the global routing table.
In another class, they mentioned like the ISR could be the control plane, and that's your WAN router like to an MPLS. So I could do that and not have this fusion, or is that acting as the fusion? I've never heard fusion terminology.
Yeah, the question is basically what devices can be your fusion router, and what can be your, did you ask about control plane too? Yeah, so the ISR routers can actually do both those functions.
Yeah.
Again, there were some slides that we hid, that we didn't go through, but that detail which devices can do what kind of role, and actually it's all bolted out in the CVD also what we tested in the test facility.
Okay.
Yeah.
So, I guess with your firewalls and wireless controllers in the same area, or because you said the wireless controller isn't part of the fabric itself, it has to be connected to devices not in the fabric.
You can have your the wireless LAN controller connected to the Fusion box. It really doesn't matter. Or you can have it in a centralized location right behind the shared services, right? You can do either deployment, right? So only thing that you got to consider up there is the latency. So there's a latency requirement for the AP to join the controller and things like that. So that would just be one of the key things. It really doesn't matter where your controller is located. The closer, the better. Can I run services? What do you mean by services? What kind of services are we? Yeah. The DHCP server should be outside, so you can run it on a Fusion box. It should be a Fusion or a centralized location, yeah.
So where is the route linking taking place?
So the route link. The route linking actually takes place in the Fusion. So what all we're doing is the VRF that we created in our fabric, we are extending it to the Fusion, and then in the Fusion we're going to do the route linking. Right.
Same as export maps, import maps.
Yeah. So it depends upon if your traditional network or your shared services are in global, you can just do redistribution, or if you put it in a VRF, then you can just do route linking with import and export commands on the VRF. Yeah, yes, you had a question?
Yeah, I might have answered it. So that Fusion box, it's taking the virtual LAN that you created. Now, is it proxying it, or is it actually publishing those IPs to the rest of your network?
It is publishing. It's basically redistributing redistributing the fabric routes throughout my network, right? Yeah. So if my DNAC has to send a DHCP reply back, it needs to know where to send it, right? So we have to advertise that subnet up here as well.
So that Fusion box is going to be owning all of the routes.
Exactly. Yeah. Right. It will be owning both fabric routes as well as my other traditional network routes as well, right? Yeah. So your Fusion box, you can use ASA, right? As long as any platform that supports VRF, as long as any platform that supports route leaking, redistribution, BGP, you can use that box.
So in your demonstration topology, you have a 3850
Mm-hmm.
doing it.
Yeah.
Is that sufficient for enterprise?
It's just a demo, so I just picked the platform that I have. That's what I'm saying. You can use any platform that can support based upon the needs it is, right? If you have your ASA, you can use ASA as a Fusion router as well.
So yesterday they explained user A could move their computer to another building.
Right.
And be in like switch 20, and
Yep.
it wouldn't know any different.
Yes.
So how, like when they plug into a different physical port on a different switch, it doesn't get put into a VLAN per se, right?
Right. Yeah. So just hold on that question for a moment, and then I'll answer that question. Right. Yes.
Back to the wireless clients. Is the client, wireless client traffic, is it locally switched, or is it tunneled back through the computer outside of that?
Yeah. So the question is, for the wireless clients, is the traffic going to be locally switched or is it centrally switched? Right.
Is it locally switched like Flex Connect, or is it tunneled back through?
Right.
Actually, neither.
Yeah.
Yeah, so it's actually, so the question is, what happens with the traffic from the AP? So we go from the wireless world, what happens, the AP decides, the parameters of the fabric, puts it in VXLAN goes, and it's locally switched at the edge switch. So not in the AP, but it is distributed on the data plane. Control plane still, so your wireless LAN controller still handles all the roaming, all the stuff that it's really good at, doing the RRM, all that kind of good stuff. Yes, one of the big advantages that we see in the wireless domain is that, yeah, it's switched right at that edge switch versus taking it all the way back.
But it's not, but the AP's configured as local, not Flex Connect.
Yeah.
But the AP's configured what?
Yeah. So just hold up for that question as well. I'm going to do the AP integration in this piece as well. So all we do is we go ahead and then provision it to a site because we know from the wireless profile that that site is part of Fabric. We automatically, the AP goes for a reload, comes back, and then brings up the VXLAN tunnel between the AP and the Fabric edge, right? Yeah. So, so for a Fabric configuration, so this is what I've done. I picked up the VRF definitions from my border, from each of my border. And then I also looked at the interface VLAN configuration on my box, on the border, and I kind of replicated the same thing on my Fusion as well. And then I've created eBGP sessions between each of my border to my Fusion router, and I've done the route leaking up in my Fusion, right? So let me go back and I'm to DNAC. So the last piece is doing host onboarding. So when I go to my host onboarding, the first selection process is choose the authentication method that I want throughout my Fabric, right? I can choose closed authentication, which is .1x based authentication mechanism. If I choose Easy Connect, it is MAC authentication bypass, MAP, and no authentication is no authentication, and open authentication is we would do .1x first, and then times out, and then we would do map, and then if it times out, then we would just connect the connect. We would just put onboard the client with the appropriate VLAN, right? So in this case, I'm going to go no authentication, right? I'm going to go click save. So when I choose this, all my access ports, all my Fabric Edge ports will basically get this default authentication template, right? Right, so I'm going to go ahead and then assign the IP pools that I created earlier to each of those virtual network, right? You can just go ahead. For the infra VN is where my APs are going to be connected to. So I'm going to go ahead, select my AP pool for that infra VN, take and apply. Right, so VN campus, this is where my clients are going to be connected to. So I'm going to just click if it's a data or a voice. I'm going to just go ahead and click data. I'm going to add my voice because my IP phones will be connected to that. I'm going to select my voice and then click update, apply. Right. So for the VN, I'm going to go ahead and create this, right? So what happens up here is once I select the pool to part of that VN, I'm going to create VLANs across each of my Fabric edges, right? So when I create the same VLAN across my, like it doesn't matter where my endpoint gets connected to, it's always going to get to that VLAN, right? So going back to your question, right? So if my client is connected to one Fabric edge, right? So because it's connected to VN campus and it's connected to a client pool, it's going to get an IP address from that. And if it moves from that Fabric edge to a different Fabric edge, even that Fabric edge is going to have the same pool, right? So it always has, it doesn't have to go back and re-authenticate it. So it's just going to carry over the same IP address up on the new Fabric edge itself, right? What's going to happen is the new Fabric edge where the client has roamed to would just send a client register message to the control plane. So the control plane knows the new location of that endpoint, right? If some other client is trying to reach this client, it basically queries the control plane, and the control plane knows where the new location is.
Conceptually, I see it as one big switch. The Fabric is a huge switch, and if you move around, it doesn't matter.
It doesn't matter, yes, exactly.
What were you adding when you clicked on the virtual network?
I was adding the IP pools to the virtual network, right? So these are the pools that I created earlier. So I'm just going to, for example, for the virtual campus. So this is where my faculty and my students are going to get connected, right? They need a pool to get an IP address, and this is what I selected here, right? So I choose if it's a data or a voice, and all I did was update. Right. I'm doing the same thing from a wireless LAN as well. So I'm just selecting a pool so that clients connected to that particular society gets an IP address from. right? So once we do this, so once I've created a pool for the infra VN, my APs would be getting an IP. What we do is we do macro, right? We do CDP. We understand it's an AP. It's a Cisco AP switch. We enable auto smart ports. Once we enable auto smart ports, we would push the appropriate VLAN to that particular endpoint. So we would push a configuration onto the ports, and the APs would get an IP address, and as a part of the DHCP pool, it would know where to go and register, right? We have option 43 configured so that it knows which controller to go register. And if I go back to my wireless LAN controller, I should be seeing my APs registered to my wireless LAN controller automatically, right? I haven't touched my switch ports or anything for it to do it. It's all automatic. It's taken care of, right? So at this point, these APs are in local mode. These are not in VXLAN mode. So in order to convert them to VXLAN mode, what we have to do is we have to go back to our provisioning tab. So the APs are still not recognized, so let me go ahead and do a quick resync for the wireless LAN controller. So the resync basically happens every 25 minutes, right? So APs just got registered to the controller, but the wireless LAN controller hasn't synced up. So let me go back to inventory, do a quick sync of my controller. So once the sync happens, we should be able to see the APs should basically show up in the provision tab. Right. So these are the two APs that it got registered. So all I would do is just select these two APs and then assign it to a site, right? I would just go ahead and then assign it to a floor. Just go ahead and select this to a floor and then apply. Next. Yeah, so I'm going to go ahead and then select the RF profile that I want this to be. I can create my own custom RF profile, or I can use the default profiles up here, right? And if you want to do a custom RF profile, you would actually do it in the design tab, right? So yeah, so this is the RF profile that I have. I'm supporting both 2.4 5 gig data rates. These are the data rates that I'm supporting for now. So all I do is I go click deploy, and basically says the AP is going to boot up and then come back in the VXLAN mode, right? So from this point on, all the control packets will go to the controller, but as all the data packets gets pointed out at the fabric edge itself. Right?
What's the latency, maximum latency you can have between DNA center and nodes in the fabric?
I'm not 100% sure about that, but
It expects to be in the LAN, though, right? It has to be within the campus, right?
Yes, right.
So.
Yeah, I believe it is like 100 milliseconds. I might have to come back. I might have to double check on that, but yeah. Right. All right, so the last section is, so let's go ahead and then start onboarding our wired clients onto the network, right, while we are waiting for the APs to come back up, right? So all I would do is, if the endpoint is capable of doing authentication, we would let ICE do the authentication, and as a part of authorization, we would send an HTTP tag, right, scalable group tag to it, right? If there are endpoints which is not capable of doing any authentication, what we can do is we can statically give an HTTP tag for those endpoints, right? For example, if IP phones cannot do MAC authentication or .1x, all I would do is I would select the port. I would put this to an appropriate VLAN, right? In this case, I'm going to select this to be a VLAN. And then I'm going to say IP pool. So this is the pool that I've created earlier in the ICE, right? So I just assign an HTTP tag statically, right? And just go ahead, click apply. Right, and And these are a couple of switches, the endpoints, which is basically a Windows machine which can do .1x. So all I have to do is I'm going to say, put it to a pool, and I'm going to say, go ahead and do closed authentication, right? So when I push the configs, the appropriate port configurations get pushed onto the switch, and basically client has to do authentication, and only then they're going to get a IP address.
What's closed authentication again?
Yeah, closed authentication is .1x, right? Yeah, right. So, yeah, so let me go ahead and then quickly check on the endpoints.
Jack, you need
Yeah,
to wrap it here.
yeah. Last bit. If I go back here, yeah. So if you go back, right. So if you see here, my Windows machine actually got an IP address from, once it got authenticated, it basically got an IP address from the DHCP server. Right? Yeah.
Is that wireless?
This is wired. Yeah.
Yeah, so we've taken it, I'm just going to do a quick wrap up here. You saw everything that Prashant went through. We were able to take the original design, go ahead and provision it out to our network. The things he intended to do by doing all that segmentation, from going from the macro segmentation down to the micro segmentation, we now have created the fabric and pushed it all out. And the conclusion here is basically all that stuff that he did. We have some additional slides that are in the PDF, but all that stuff is in the Cisco Validated Design. You can take it step by step through everything he did. Those are out there on cisco.com/go/CVD. And in any of those guides, if you have any suggestions or anything you want feedback on, there are links at the back of them. You can tell us exactly what you'd like to see us do to improve the guides for your use. And of course, fill out your session evaluation. Appreciate your time and all the good questions.
Thank you.